couple things about me. My name is Mike Graham. I'm a systems engineer here at 7Signal. I have been here, I think this is my 8th year. When I was preparing for this, I noticed that we've changed to 2023, and I installed my first wireless LAN in 1993. So yeah, 30 years in wireless LANs. It's kind of come a long way. Those first ones we installed were 450 megahertz land mobile band, 2 speeds. 9.6K was high speed and 4.8K was standard.
Oh my.
And that's K bits, not K bytes.
Right.
Yeah, but the range was miles. So yeah, that was it's been a long time. And then sort of I thought I would address why I decided to do this. And I guess it was back before the holidays. I was on 3 or 4 calls in a row, and we were looking at Mobileye, our agent, and we kept seeing, well, here's a client that's doing well, and then suddenly we see some performance challenges, and then it goes back. And when we would investigate, we would say, oh, it roamed on the 2.4, and that's when the throughput fell off and the voice quality fell off, and saw it several times in a row with different customers, and kind of went on a little rant about 2.4 and decided that, maybe we would talk about it on a webinar. I imagine you've probably seen the same thing, Jim, on Mobileye investigations.
Yeah, absolutely. Common problem, especially in the enterprise where you have higher densities of APs.
Yeah, the density is a big problem. So I put together a few slides on my rant. I thought we could talk about those a little bit today. First off, should we be using it? And if so, for what? We know that there's a lot of problems. We have interference issues. We have some constrained designs compared to 5 and 6 gigahertz, limited performance available, and some limited spectrum there. Thought I would pull up one of our spectrum graphs, and this was just sort of a junky one that I found, and you'll notice that yeah, you can hardly even really pick out the Wi-Fi in there. That's a spectrum that you're going to have a hard time getting good performance in. And just as a comparison, down in the on the right side, I snagged a Stumbler view, basically the Wi-Fi that we see, and you can see it doesn't match up all that well. I imagine you probably see that a lot too, Jim.
Yeah, and yeah, it's
Yeah.
something that you look at with every customer now, just because it's exceedingly rare to find only Wi-Fi operating in 2.4 gigahertz anymore.
It is. This is probably Bluetooth, some kind of hopper, but yeah, it could be anything out there. The next up is the constrained designs, and I pulled this out of a big airport that we're in. This is channel utilization over a week. It's the QBSS value, so we get that from the access point. It's calculated as part of its channel assessment, broadcasting the beacons to give some load information on the network to the clients. 2.4 channel 6, and yeah, you can see that in the early hours of the mornings it gets as low as 40-45%, and during the midday hours every day it's over 90% channel utilization. I looked at the number of users on the access points on 2.4. For the nearby APs, 0 to 3 users all day long. So I took a look at the traffic on it, see what that was. A lot of it is corrupt frames, the access points that are just too distant to quite receive the whole frame, at least without error. And most of them are probe responses. What we find is that clients are going to probe on all the channels. They're going to send broadcast probes. They're going to do it at 1 megabit per second on 2.4. And that 1 megabit per second really travels, which can be a good thing. In this case, it's not so much. And every access point that hears that 1 megabit probe response or probe request is going to respond. So it can really just eat a channel alive. There's no data traffic on this. Yeah.
This is the kind of thing too, where a customer would say, wow, this network is super busy. What's all this traffic? It's like, well, just overhead.
Yeah, it is.
There's nothing meaningful happening on the network. It's just overhead.
Yeah, there's some beacons, and the rest of it are probe responses. It's basically all management traffic. And we see this particularly on 2.4. A lot of it is because of that 1 megabit probe request that just travels, and every AP has got to respond to it. The next one, limited performance. I pulled this out of the same site. It's as close as I could come to apples. They're both 20 megahertz channels. They're both 3 spatial stream APs. The pink is 2.4 802.11n. The gold is AC, and huge performance difference. And we see the same thing on voice quality. A lot of packet loss, a lot of jitter on 2.4. Much better performance on 5 gig. And once again, there's 0 to 3 users on that 2.4 network in here. So you roam on to 2.4 and you sort of pay the consequences for it. We all know the throughput. And by the way, I went in and looked at the data rates, and really, the 5 gig offers higher potential data rates, AC versus N. But what I really found was it was that interference, the channel utilization, the noise on the channel. 5 gig was mostly at very high MCS indices, high modulation rates. 2.4, it was struggling to hit, 50 megabits over the air on this. It's just hard to get performance out of 2.4. And then finally, the limited spectrum. 3 channels, non-overlapping on 2.4, at least in the US. 25 and 5 gig, 59 and 6. So it's only 3.4%. I did some charts laid out. The camels, because it sounds sort of like channel, at least it did late last night when I was putting this together. But I think that there's an argument to be made that, maybe we don't need those channels with all of the 5 gig and now 6 gig channels. What do you think, Jim? Can we survive without a few 2.4 channels?
Yeah, I mean, as long as our clients can use the other bands, absolutely can.
And that can be an issue. And I kind of bring that up. The other side of 2.4, it's the good and the bad. It's very robust. We get great penetration, at least compared to 5 and 6 gig of walls, other obstructions. You can fall all the way back potentially to 1 megabit, and really even pretty ordinary cards will get a decent connection all the way down to -95 and sometimes below -100 dB at 1 megabit. So it really travels when you need that deep penetration. And as you were bringing up, it's widely supported. Basically every wireless LAN device in the last 25 years has supported 2.4. And it's allowed almost everywhere in the world. So if you need that compatibility, you do have 2.4 there. Wouldn't you say?
Yeah, and actually it seems like it's growing. Seems like more and more not pure IoT, but low end devices
yeah,
are 2.4 only.
That's the case. And I sort of summarize it with the user experience issues. We know that they have problems when they roam onto 2.4. We'll see them do that really for no clearly apparent reason. And like at that airport, there were very few actual clients connected onto 2.4. But as we see in Mobileye, clients will sometimes, and really for no clear reason, roam onto 2.4, 10 minutes, half an hour, and roam back. And there's very little control over what the client card does, because it's so hard to design these large dense networks. We see what it does to channel utilization, even if really there's nobody on it. It makes them difficult to design. You have those pretty unpredictable interference. Very few clients require 2.4. We don't really need those channels. So I think a good argument for not doing 2.4. But then, where do you use it? As you said, where we need the compatibility. There are still low-end 2.4 devices out there, 2.4 only. So big public venues, you almost have to. Warehousing and industrial, a lot of those devices are hardened devices. That means they last a long time. That means they're very expensive, so they don't get replaced a lot. Medical, hard to get things certified sometimes. Those devices, once they're up and running, there's a lot of reluctance to make changes. And as you mentioned, IoT devices, the airport from the previous graphs, and I was a little surprised to learn this, have IoT soap dispensers in the restrooms. They call in periodically and update the level of soap in them so they know when they need to be serviced. I thought that was pretty cool IoT, but they're super low power devices that, so yeah, there are some of those. And of course, where you need the robustness, you do have obstructed and difficult environments. You do have large areas. I mean, some manufacturing and industrial, you'll have more access points than you will users. You don't really need the capacity of 5 gig. And of course, outdoors, if you've got a field or a parking lot that needs to be covered, it's hard to beat 2.4 in a big sector. And usually you don't need the performance. Did I miss any big ones there? Did I get anything wrong on that, Jim?
Well, just my own observation is that in-home networks, consumer networks, there's just over the last couple of years been an increase in 2.4 gigahertz only devices. My watch is 2.4 gigahertz only. My bike computer is 2.4 gigahertz only. I've got all this new Wi-Fi stuff, and they build it as cheaply as possible. My thermostat is 2.4 gigahertz only, and most of it's 802.11n. It's older stuff. It's clear they just went with the absolute cheapest Wi-Fi solution they could deploy, and actually it works just fine because the application requirements are so low. But I had hoped, being a wireless nerd, I could get rid of 2.4 gigahertz in my house eventually, and the dependence on it has just grown over time.
I've actually seen the same thing. I had 2.4 turned off on my home network altogether.
Yeah.
And I broke out an old tablet with the idea to repurpose it for a new application. And I'm like, well, why can't I get it connected to my wireless network? It doesn't see my network. And it actually took me a while to realize it was a 2.4 only device.
Mm-hmm.
It was kind of upsetting, actually. But yeah, you're right. We are definitely seeing that, I'm calling it home IoT, home automation devices that are 2.4 only. It's a good application. You know, you need the range.
Yeah.
You need the, you want to be able to talk to the thermostat upstairs or whatever. That sort of 1 megabit negative 95 or better is plenty. You know, the data rates are plenty. So yeah, it's a good application, but annoying when you've turned off 2.4 in your house.
Mm-hmm.
So, you know, some recommendations only if you really, really need 2.4. I think for most carpeted areas, you know, office type spaces, we probably turn it off only for low density, both low user density and low access point density applications. Minimum number of APs. You know, try to hold down that management traffic explosion. And a lot of that is the number of APs. If you've got hundreds of 2.4 APs, you're going to have those performance problems. Minimum number of SSIDs, same thing. Every SSID is going to create management traffic, very much like an independent physical access point. And I don't think anybody needs those 11B rates. You know, maybe if you have an application where it is IoT and you're doing that, you know, update the soap level in the dispenser or control the thermostat or something. But mostly you don't need B anymore. So I think we can start turning those off. Other thoughts on 2.4, Jim?
No, I think we got it covered.
Yeah. But yeah, for real, if you have it turned on, you have the same SSID. We see all the time clients will roam onto it and start with very poor performance. I've talked to some customers about if they really have to have it, give it an unattractive name, you know, and company name _ legacy Wi-Fi, something like that. Make it a little less attractive for users to attach to. Give it a different SSID so the devices don't automatically roam onto it. And definitely it will cut back on some of those. Everything was fine, then it wasn't, then it was issues with Wi-Fi. And in the office, you know, mostly it's voice over IP, it's video conferencing, and those are really impacted when you roam on the 2.4. And I think that's about it.
Great.
Yeah.
Yeah, one thing I'd add too, just and something I've done at home is it's not necessarily a bad thing that IoT is 2.4 only, because it's slow and it's not real time. And I'm very happy that all this IoT stuff isn't competing for channel access with my laptop while I'm in a webinar, right? So
that's a good point.
It also, the other thing about that is if you think about your SSIDs, you could set up an IoT only SSID. And that gives you the opportunity to apply some really strict firewall policies, right? Because again, like I don't want my thermostat, which is probably riddled with a bunch of security vulnerabilities, because it's not, it's just, I'm just fairly certain it is. I don't want it to have direct access to everything else on my network and be a potential point of intrusion. So something to think about there.
Yeah, that's a good idea. We see that sometimes where we have legacy devices that don't support good security and you put those on their own SSID, their own VLAN, you firewall them down, and if somebody does penetrate it, you hope to limit the damage.
Yeah, it's so simple if they're on their own SSID to get all that set up, even with home networking kit. Joe in the chat says, "You mean you don't patch your toaster on a regular basis?" I would never connect something that could start a fire to the internet in my home.
Yeah, if somebody I think posted on a Slack channel, Wi-Fi remote control for cars, and we were all like, I hope they really don't mean Wi-Fi. I hope it's just short for wireless, because that would be a little scary.
So we do have some good questions that have come in, and we've got plenty of time to tackle some of these. And anybody in the audience that has a question, drop it in the Q&A panel. We'll try and get to it too. Anders, with the first question, says the real question we will have is, will we have the same discussion 3 years from now about 5 gigahertz telling everyone to go to 6 gigahertz?
I don't think so.
Yeah,
I don't know. I don't think so. The characteristics of 5 gig and 6 gig are really pretty close compared to 2.4. That physical layer is quite different. Spectrum availability is quite different. Yeah, I don't think we're going to be walking away. Of course, we did walk away from 900 for high performance data applications.
Yeah, 900 is coming right back. The 915 megahertz band in the US for IoT stuff, LoRaWAN, Halo, and other things.
And they're happy not to have a lot of Wi-Fi type data traffic on it.
Yeah, I think you're right. I mean, there's still so much capacity and so much spectrum in 5 gigahertz.
Yeah.
In fact, I've been thinking more and more of 5 gigahertz and 6 gigahertz really just being one single band. There's just a little bit of spectrum in between, but they really are kind of like one big contiguous band. And if you did have, let's say, thought experiment, all your clients supported 5 and 6 gigahertz, you could design 5 and 6 gigahertz as a single coverage layer, actually, to get the the absolute maximum channel reuse that way. So maybe 3 years from now we'll be designing networks that way, but I don't think we'll ever just completely give up 5.
Yeah, I agree.
It's a question from Nick. He says, there's perception by some people who do not fully understand how Wi-Fi works that deploying a 5 gigahertz only network will cost more money. How would you convince these people that a 5 gig only design is a better investment? Well, I would say it costs more than what? More than doing a 2.4 gigahertz only design, which that's easy to counter because you can show that at any kind of normal density that we use in the enterprise, it won't meet the requirements of the applications you're using. So yeah, it's cheaper to do 2.4 gigahertz only, but it won't work. And also, you can't buy APs that don't have 5 gigahertz radios anymore. I don't think you can. Maybe on eBay somewhere.
Yeah, I don't think you can either. And I've often thought that if access points did not have multiple radios, so that you were forced to do separate designs for 2, 4, and 5, we would probably get better quality networks.
Yeah, absolutely. Because you have to decide on one band over the other for your design. Today we design for 5 gigahertz, and then we just kind of look at the huge overpopulation of 2.4 gigahertz radios and decides which ones we'll actually use.
Or we
Which,
leave them all turned on, which is
yeah,
super
well,
common. Is every
yeah,
AP is running 2, 4, and 5, and it's designed for 5. And I really don't see a lot of network designs anymore that are 2, 4 oriented.
no.
Even in warehousing and industrial and things like that, they're usually designed around 5.
Yeah, I think I can think of one customer that has it in a warehouse, and I think that's driven by some very old clients. They might be 802.11b clients, if I remember correctly. So
And yeah, like I mentioned, warehousing is one of those places you pay so much for the clients because they're typically hardened. Um, they typically last a long time. You don't want to replace them. They do the job. So yeah.
quick one from an anonymous attendee who's embarrassed to ask this question, I guess, but we'll take it. Can you possibly explain why most whole home mesh systems use the same channel on all the boxes? And I can explain that. That's because in order to be built as cheaply as possible, they use the same radio for client access as they use for the mesh backhaul. And since all the mesh radios need to be on the same channel to communicate with each other, that means everything is on the same channel, the mesh backhaul and the client access, because it's all coming from the same radio. It
Yeah.
doubles the cost to build a separate backhaul radio, even though that's a performance boost.
Yeah. That actually bugs me a little bit. It doesn't double the cost. It adds $50 or something to the cost. Of course, I guess in a
Yeah.
home class device, that is kind of doubling the cost.
Yeah, and it's interesting that the higher end mesh systems that do have multiple radios are a lot more than $50 more, even though you're right, the chipsets aren't
Yeah.
aren't that much more.
But very, very true. I used to work for FireTide, which is a mesh company. And our radios, our mesh nodes, were dual radio. They had 2 dual band radios, so that you could run them on separate channels. And that made a big difference in mesh performance. You could run long chains of those with very little throughput degradation. Unlike that single radio where you have to turn the radio around for every frame and retransmit it, and it's a big impact. But definitely a performance issue with single radio on those mesh units.
Mm-hmm. Some love for FireTide from Kenneth in the chat. Thank you, Kenneth. Let's go to Rob, who says, have you seen high density areas where you reduce the 2.4 radios on many of the APs because you don't need that many, but the end result is the power level goes up on 2.4 and the devices prefer them, pushing more devices to 2.4? But that's exactly what will happen if RRM is running wild without any restraint. Yes, that is what will happen, Rob. So I have seen that many times.
I have to, absolutely. Yeah. And it's an appropriate response from RRM, and it's fine if you don't have them on the same SSIDs so that they won't roam. Because I think fewer APs and a little hotter on the radios is a good design for 2.4.
Yeah.
The density is more of a problem than too much power, I think.
Yeah, and if you do have a dual band SSID, and there's different schools of thought on if that's a good idea or not. But if you do, go into your RRM or whatever it is that's setting the transmit power and put a hard limit on how high it'll go. And make sure it's, below where your 5 gigahertz radios are ending up. So So you want your dual band clients to always get the hottest signal from the nearest 5 gigahertz radio, which will influence their roaming.
Yeah, I agree. You definitely want to back down the power on 2.4 if you're going to do the same SSID on both bands. Because that strong signal on 2.4 is very attractive. Drivers are dumb, and they will, not every time, but too frequently, they will just go for the strongest signal, period.
So last question here, unless anybody else wants to drop something in the Q&A. Question is the coverage of 2.4 gigahertz more than 5 gigahertz true, even if transmit power is double on the 5 gigahertz band?
No.
Yeah, I said the same thing before I even finished the rest of it. And
Yeah,
he's got some power, 20 dB versus 23. So the answer is no.
now, if it's clear open space, propagation is ever so slightly better on 2.4. If it's obstructed space, propagation is quite a bit better on 2.4 if there's walls to penetrate. But yeah, at least in free space, yeah, it's a small difference.
Yeah, and it's around 6 or 7 dB, because of the differences in receive aperture between the two bands that you'll get. So if you want it to be even, and you probably don't, you probably want 5 gigahertz to be even louder than 2.4 most of the time. You want to go at least above 6 dB, maybe 8 or 9 dB, even better, to get clients to really choose 5 gigahertz over 2.4.
That's sort of the same values I use. 6 to 8 dB back down on 2.4.
Mm-hmm.
Seems like a reasonable value.
All right.
Is that it?
I think so.
All right.
Great, then it is time for us to awaken Eric. You with us, buddy? Oh, there he is.
Emerging from the abyss.
Yes.
It is my sincere pleasure to be here. Thank you very much. Yeah, Mike, awesome stuff. Really appreciate it. Always fun just listening to you because of all of your experience, and I just love it to death. But as we know, everybody, it is that time. It's time for 7 Minutes with 7 Signal, where we take a little feature inside 7 Signal, unpack it, and show you how it can have awesome value. So come on, let's take a look. I'm going to share my screen here. And we're going to take a look at Mobileye today. You know, Mike did a great job of looking at some screenshots inside of Sapphire Eye. We're going to take a look at some screenshots inside of Mobileye, which is that little itty bitty piece of software that we put on your laptop computers that can tell you everything that your laptop computer is up to. It's pretty awesome. So can you guys see my screen? Just give me the thumbs up if you can. All right. So here we go, guys. Because of everything that we've talked about today, we know that there are these performance differences between 2.4 and 5 gigahertz. What that means is that we need to be able to uncover and discover not only when it's happening, but with additional detail, even unpack why it's happening. And so one of the things that we've done inside Mobileye here is we've created a report because of just how important this issue is. So I'm going to go to reports here and check this out. We actually have a report called Show Me Problems for folks that are on 2.4. Because we really truly want to identify, we want to single them out. We want to separate them so that we can see what is going on. What kinds of devices do they have? What are the conditions taking place that are causing their devices maybe to roam inadvertently to 2.4? So we need to take a look. We need detail, and that's what we're here to provide. So let's just click on that report right here. And I'm running a report for the last 3 days. I can run this for yesterday, the last 7 days, 2 weeks ago, whatever I want. And then what I'm going to do is I'm just going to click on the Show All Clients link. And right here on the left here, you can see these are the names of different people who work for 7 Signal and their devices. And what we're doing is, first and foremost, we're looking at Wi-Fi quality. Wi-Fi quality is kind of an aggregate score. It's based upon MCS, and it's a score based upon the channel width and the spatial streams of the client, as well as the data rate. And what we want to be able to do is we want to take all of that information and determine, hey, based upon all of these factors, is somebody having a good Wi-Fi experience or not? All right. They might not be, based upon the fact that they're on 2.4. Let's take a look at one of these devices. I just found this one right here, this MacBook Pro. And I thought that this was a good example because based upon our experience, MacBooks have a tendency to choose 5 gigahertz like all the time. It's like it's built into them. Must choose 5 gigahertz. Use 2.4 only as a last resort. So that's why I thought that this was an interesting example. So I'm going to click on that one right there. And when I do, it's going to take me in and look at what shows up right away on the Land Before Time network. So this is somebody who's trying to be productive at home, and maybe they're not. They're not productive. They call in, what can I do in order to be more productive working at home? And all I need to do is take a look at this picture here and see just what a mess the 2.4 gigahertz spectrum is. It is messy. These are all what we would call noisy neighbors that are all around in the apartment building or whatever it might be. Okay, and you can see that the device is certainly capable of being on 5 gigahertz. Let's take a look at what the 5 gigahertz network looks like. So I mouse over one of these dots. Okay, and there you have it right there. Okay, now actually what's really interesting is that on 5 gigahertz, you can see Land Before Time in blue. That's a 80 megahertz wide channel that's bonded. And it's also highlighted in red the interference that's all around them, the adjacent channel interference. These are, again, these are noisy Wi-Fi neighbors who are potentially causing a problem. But look at this, guys, just like what we pointed out a moment ago. 2.4, not a whole lot of spectrum to work with. Okay, not a whole lot of spectrum at all. It's really busy. Look at that. There's no white space whatsoever, if you will. But when I go over here to 5 gigahertz, wow, there's all sorts of opportunity to spread out. Okay, now maybe your router isn't your home router isn't capable of using the DFS channels. Usually there's just like channel bonding on channel 36, where you can do an 80 megahertz wide channel primary on 149. That's what we typically see, that the cable companies with the routers that they give you, they only allow you to do that. But look over here, guys. If I was trying to help this person, I would say, look, there's a much better opportunity for great performance if you were to kind of go into that router and you were to switch it over to channel 36 here, because it is much smoother sailing. And that's what we do with interference. It's like, we're not going to knock on somebody's door and say, hey, cut it out, right? Because it's free. They're entitled to use it. So instead, what we use is 7 signal to see where it's noisy. Oh boy, noisy on 2.4, yikes. Where it's not noisy, wow, look at all that smooth air, if you will. And then what we can do is we can avoid the interference, and we can set up shop where it's less noisy, where there's a lot less activity going on. And in this case, I would recommend, hey, let's move on over here where I think you're going to have a much better experience. So there you have it, guys. That's what I wanted to share with you today. So interesting to be able to see what your computer is doing from its point of view, the decisions it's making. And not only can I see the flip-flop between 2, 4, and 5, but I can also correlate that to the signal to noise ratio and how that's going to impact throughput and voice quality as well. So there you have it. Good stuff. And, you know, I just want to remind everybody out there, very importantly, that while you and me, we can't see or hear Wi-Fi, 7 Signal can. Thanks for joining us today, and back to you, Heather.
Awesome. Thank you, Eric. Thanks, Mike. Thanks, Jim. Thanks to all of you for being here today. Always wonderful every single Wednesday. And you know where we will be, same time, same place next week. So we will see you there. Bye-bye.
Bye, everybody.